Hey there, buddy. Welcome back. Are you ready for another deep dive?
I am.
Great. So last time we talked about the history of board games.
Right.
And this time we're going to dive into something I know you absolutely love. It's a game filled with colorful cards and tons of cool pictures.
Can you give me a hint?
Well, you have to be super quick to find the matching picture between any two cards.
Oh, I know. Dobble.
You got it. Dobble, or as some people call it, spot it.
It's one of my favorite games.
Mine too. It's so much fun, and you have to think fast.
You definitely do.
But have you ever wondered how they came up with all those cards and pictures?
Now that you mention it, I have wondered about that.
Well, I did some digging, and it turns out there's a ton of math behind this game.
Really? Math. I didn't realize Dobble was so mathematical.
I know, right? It's pretty amazing. In fact, a really smart mathematician named Dr. Peter Collingridge investigated this very topic.
Wow. A mathematician.
Yep, he was curious too.
Yeah.
He wrote a whole article about the math behind Dobble, and we're going to explore it together today.
That sounds really interesting.
And you know what else? Other people have been fascinated by Dobble too, like Kevin Raymond.
I don't know him.
He's a software developer who wrote about some interesting things he noticed about the game. And then there's Lori M.
Who's that?
They also had some intriguing observations about Dobble that we'll talk about later.
So we have all this cool information from a mathematician, a software developer, and someone named Lori M. This is going to be a deep dive for sure.
You bet. But before we jump into all the math, let's quickly remind ourselves how to play Dobble, just in case anyone forgot.
Good idea. I'm sure everyone knows, but a quick refresher never hurts.
So we have these cards, right?
Right. And they're covered in all sorts of fun pictures.
Exactly. And the goal is to be the first one to find the one matching picture between any two cards.
It's like a race. You have to be really quick.
Exactly. And sometimes you might feel like you see some pictures more often than others. Have you ever noticed that?
Now that you mention it.
Don't worry. We'll uncover that mystery as we go deeper into our deep dive.
Okay, I'm ready to unravel these Dobble secrets.
Now, to understand how Dobble works, we need to explore a fascinating area of math called combinatorics.
Combinatorics. That sounds like a big word.
It is a bit of a mouthful, but it's actually pretty simple.
What is it?
Well, combinatorics is all about counting and arranging things. It's like figuring out how many different ways you can arrange your toys.
Oh, so it's like sorting and organizing, but with math.
You got it. And in Dobble, instead of toys, we're dealing with those cool pictures on the cards. Dr. Collingridge calls these pictures symbols.
Symbols. So each picture is like a secret code.
You can think of it that way.
Yeah.
And we also have the cards themselves. Each card has a certain number of these symbols on it.
Okay, that makes sense. So we have symbols on cards.
And to keep things organized, Dr. Collingridge uses special letters. He uses N for the total number of symbols, K for the number of cards, and ES for the number of symbols on each card.
N for symbols, K for cards, and ES for symbols per card. Got it.
Perfect. Now let's start simple. Imagine a tiny Dobble deck with only 3 symbols: a star, a circle, and a square.
3 symbols. A star, a circle, and a square. I can picture that.
Now with those 3 symbols, we can actually make 3 unique cards.
How's that?
Well, the first card could have a star and a circle, and the second card could have a star and a square, and the third card could have the circle and the square.
Oh, I see. So each card shares one symbol with every other card. That's how you always find a match.
Exactly. That's the magic of Dobble. No matter which 2 cards you pick, there's always one and only one matching symbol.
That's so clever. But
Yeah.
wouldn't it be too easy if every card had, say, just the star on it?
You're absolutely right. If every card had the same symbol, it wouldn't be much of a challenge, would it?
No, it wouldn't be any fun at all.
Exactly. We need to make sure the game is challenging and exciting.
So how do we do that?
Well, to create a Dobble deck that's both fun and engaging, we need to follow a few requirements.
Requirements, like rules.
You can think of them as guidelines. First, every single card has to be unique. No duplicates allowed.
That makes sense. We want variety and surprises.
Second, we want to use all of our symbols at least once. We wouldn't want any symbols feeling left out, would we?
No way. We need all the symbols to be part of the fun.
And lastly, no single symbol can be on every single card.
Okay, that makes sense. So no symbol can be a show-off and be on every card.
Exactly. These requirements ensure that our Dobble deck is balanced and challenging. Now, the big question is, how do we figure out how many symbols we need to create a good Dobble deck?
That is a good question. It can't be just any random number of symbols, right?
You're right. There's a method to the madness. To answer that, we need to explore a really cool idea called the pigeonhole principle.
Pigeonhole principle, what's that?
Imagine you have a flock of pigeons and a bunch of pigeonholes for them to stay in.
Okay, I can picture that. Lots of pigeons and lots of little houses for them.
Now, what happens if you have more pigeons than pigeonholes?
Well, some of those pigeons are going to have to share a pigeonhole.
You got it. And that's exactly what the pigeonhole principle tells us. If you have more pigeons than pigeonholes, then at least one pigeonhole must have more than one pigeon in it.
That seems pretty obvious, but how does that apply to Dobble? We don't have pigeons or pigeonholes in the game.
It's an analogy. Think about it. Sometimes we have more symbols than we have spaces on our cards for them.
Oh, I see. So just like the pigeons, some of the symbols have to share a spot on a card.
Exactly. That's why we sometimes see the same symbol on multiple cards. It's all about fitting everything in.
That's a neat way to think about it.
But how do we know how to balance the number of symbols and cards to make a good Dobble deck?
Yeah, how do we do that?
Well, this is where those fascinating triangular numbers come in.
Triangular numbers, they sound interesting. Do they have something to do with triangles?
They absolutely do. Remember our tiny Dobble deck with the star, circle, and square? If we had just one symbol per card, we could only make one card right.
Right, just one.
But with two symbols per card, we can make 3 cards.
And with 3 symbols per card.
You can make 6 cards. Do you see a pattern emerging?
1, 3, 6. The numbers are getting bigger, but in a specific way, like steps.
You're getting it. And if we were to represent these numbers visually, they form a triangle shape. Like if you stack blocks, 1 on top, then 2 below, then 3 below that, you get a triangle.
Wow, that's cool. So those are triangular numbers that form a triangle shape.
You got it. And these triangular numbers are essential for creating Dobble decks.
Really? But why? What makes them so special for Dobble?
They have a special property that allows us to make sure every symbol appears the same number of times, but not on every card. It's all about balance and fairness.
That sounds pretty important for a game like Dobble.
It is. And the coolest part is that there's a formula to calculate these triangular numbers. We take the number of symbols per card, multiply by itself plus 1, and then divide the whole thing by 2.
That's a neat little trick. So with that formula, we can figure out how many cards we can make based on the number of symbols per card.
Exactly. And it gets even more exciting. Now, to really visualize the magic of Dobble, we're going to organize all these symbols and cards into something called a matrix.
A matrix, like something from the movies.
It's not quite as action-packed, but it's just as cool. A matrix is like a big chart or a grid with rows and columns.
Okay, I can picture that. So what do we put in this matrix?
Well, each row in the matrix represents a card in our Dobble deck, and each column represents a symbol. So if a card has a particular symbol, we mark it in the corresponding row and column.
Ah, I see. So the matrix shows us which symbols are on each card, like a map of our Dobble deck.
You got it. Matrices are like our secret decoder rings, helping us to see the hidden patterns in Dobble.
This is getting really interesting. So these matrices help us understand why certain numbers of symbols work better than others for creating Dobble decks.
Exactly. They show us the relationships between the cards and symbols, and they help us to create decks that are balanced and challenging.
And I bet this is how we'll figure out why some symbols seem to appear more often than others.
You're on the right track. It turns out that we can actually control how many times a symbol appears in our Dobble deck.
Wait, really? How do we do that?
That's what we're going to explore next. It's all about finding that sweet spot repeating symbols just enough to create a good number of cards without making the game too easy. We want players to have to think and search a little bit.
That makes sense. If the matching symbols were too easy to find, it wouldn't be as much fun.
Exactly. It's all about balance.
So how do we find that balance?
Well, mathematicians have discovered a special group of numbers that help us do just that. They're called Dobble numbers.
Dobble numbers, those sound important.
They are. Dobble numbers are like the VIPs of Dobble creation. They represent that perfect combination of cards and symbols to make the game just challenging enough.
Wow, that's cool. So how do we find these Dobble numbers?
There's another clever formula for that. To find a Dobble number, you take the number of symbols per card, square it, multiply by itself, subtract the number of symbols per card, and then add 1.
Wow. It's like a magic spell for creating the perfect Dobble deck.
And here's a fascinating fact. The standard Dobble game you play, the one with 55 cards, is actually based on the Dobble number 57.
55 cards, Dobble number 57. Wait a minute, something doesn't seem quite right there.
You're right, there's a little twist to that, and it's connected to what Kevin Raymond observed about the game. They could have created a 57-card deck based on the Dobble number for 8 symbols per card.
They didn't.
Nope, they went with 55 instead. Maybe 57 just didn't feel like the right number for a game.
I guess 55 does sound better.
Right, it's like a little behind-the-scenes secret of the game.
That's pretty neat.
And guess what? The Bobble Kids version, with 6 symbols per card, has 31 cards, which is the Dobble number for 6.
So both versions are based on these Dobble numbers.
Exactly. They ensure that each version of the game is fun and challenging for different ages.
Wow, math is really powerful. It can even help us design games.
It sure can. But wait, there's more. The math behind Dobble is also connected to geometry.
Geometry. The study of shapes and lines. What does that have to do with Dobble?
Get ready for this. In Dobble, we can think of each symbol as a point, and each card as a line connecting those points.
What? So it's like those connect the dots puzzles?
It's a bit like that. Each symbol is a dot, and the cards are the lines connecting them. And there's a remarkable geometric shape called the phanoplane that perfectly illustrates this relationship between Dobble cards and symbols.
A phanoplane. It sounds kind of mysterious.
It is pretty cool. We'll dive into the phanoplane and see how it unlocks even more secrets of Dobble in the next part of our deep dive.
Awesome. I can't wait to learn more.
All right, are you ready to unlock more Dobble secrets with the phanoplane?
I am. It sounds so intriguing, like something out of a mystery novel.
It kind of is. Imagine this. A triangle with a dot right in the center.
Okay, I'm picturing it.
Now draw lines from each corner of that triangle to the center dot.
Okay, got it.
And then connect the corners of the triangle to each other, creating another triangle inside the first one.
So like a triangle within a triangle.
That's it. That's the phanoplane. It has 7 dots, which we call points, and 7 lines.
7 points, 7 lines. That reminds me of something.
What is it?
Well, each line in the phanoplane goes through 3 points, right?
That's right.
And in Dobble, each card has a certain number of symbols.
You're getting it. The phanoplane is a visual representation of how the cards and symbols are connected in Dobble.
Wow. So each point in the phanoplane could represent a symbol, and each line could represent a card with those symbols on it.
Exactly. It's like a secret blueprint for creating Dobble decks.
That's incredible. I never realized there was so much geometry hidden within Dobble.
It's amazing, right? It shows how math can connect things that seem totally different at first glance.
Like cards and shapes.
It makes you wonder how many other mathematical secrets are hidden in the world around us.
I bet there are tons. It makes you want to look for them everywhere.
Exactly. That's the beauty of a deep dive. It opens your eyes to new possibilities.
This deep dive has been a real eye-opener. I've learned so much about Dobble, combinatorics, triangular numbers, matrices, double numbers, and even geometry.
Me too. It's amazing how much math there is packed into a simple card game.
So what have we learned today?
Well, we started with those basic rules of double find the matching symbol between 2 cards.
Right. It sounds so simple, but there's a lot going on behind the scenes.
Exactly. We dug into combinatorics, which is all about counting and arranging things.
And we found out about those cool triangular numbers that help create balanced decks.
Yeah, like making sure everyone gets a slice of cake.
And those matrices, they were like our detective tools, helping us to see the patterns and connections between the cards and symbols.
And of course, we can't forget those VIPs of Dobble creation, the Dobble numbers.
They're like the secret ingredient that makes the game just right.
I mean, we even uncovered that little mystery of why the regular deck has 55 cards instead of 57.
Probably because 55 just sounds better.
It does have a nice ring to it. And then we went even further and explored the connection between Dobble and geometry.
It's mind-blowing. Each symbol is a point, each card is a line, and the phanoplane shows us how it all fits together.
This deep dive has been a wild ride. It shows that math isn't just about boring formulas. It's a way to understand the world around us.
And it can even help us design awesome games like Dobble.
It's pretty incredible, right?
So, what's next? What other secrets are we going to unlock?
Well, in the final part of our deep dive, we're going to put all of this knowledge to the test.
How do you mean?
We're going to try and design our own mini Dobble deck.
Whoa, really? That sounds like a challenge.
It will be, but I think we're ready for it.
I'm in. Let's do it.
Okay, so we've learned all about the math behind Dobble. Now, are you ready to put our detective hats on and try to design our own mini Dobble deck?
I'm ready. But how do we even start?
Well, let's remember the key ingredients. We need symbols, cards, and those special Dobble numbers.
Right. Those Dobble numbers are like our secret recipe for success.
Exactly. So let's start with a small Dobble number, something manageable. How about 7?
7, okay. So how many symbols and cards do we need for a double number of 7?
Well, remember that formula. To get a double number, you square the number of symbols per card, subtract the number of symbols per card, and then add 1.
Right. So to get 7 as our double number, we need to figure out what number, when we do all that math, gives us 7. This is like a puzzle.
It is a puzzle, and a fun one. Let's try a few numbers and see if we can crack the code. What if we start with 3 symbols per card?
Okay, 3 symbols per card. So 3 squared is 9, minus 3 is 6, plus 1 is 7. We got it.
You're a math whiz. So to make a mini double deck with a double number of 7, we need 3 symbols per card.
Cool. But how many cards do we need?
Well, with a double number of 7, we also need 7 cards. Remember, the double number tells us both the number of cards and how to calculate the symbols.
Right, so 7 cards with 3 symbols on each card. That's 21 symbols in total, right?
You're on a roll. But remember, we don't want to just use any 21 symbols. We need to make sure each card shares only 1 symbol with every other card. That's the Dobble rule.
Oh, yeah, that's the trickiest part. How can we do that?
Let's think back to our tiny Dobble deck with the star, circle, and square. Each card shared 1 symbol with every other card, right?
Right. So maybe we can use that same idea, but with more symbols.
Exactly. Let's start with our first card. We'll call it card 1. What 3 symbols do you want to put on it?
How about a sun, a moon, and a star?
Perfect. Now, for card 2, it needs to share 1 symbol with card 1, but the other 2 symbols need to be different.
Okay, so card 2 could have the sun, a cloud, and a raindrop.
Excellent. Now, for card 3, it needs to share 1 symbol with card 1 and 1 symbol with card 2, but the third symbol needs to be brand new.
Got it. So card 3 could have the moon, the cloud, and a lightning bolt.
You're a natural at this. See how we're building our deck, making sure each card follows the Dobble rule?
This is fun. It's like solving a giant puzzle.
It is. And we can keep going like this, creating new cards and carefully choosing symbols to make sure they only share 1 with each of the previous cards.
So for card 4, we could have the star, the raindrop, and maybe a rainbow.
Perfect. You're getting the hang of it. We could keep going and create all 7 cards for our mini Dobble deck.
And then we could actually play it.
Exactly. We have our very own custom-made Dobble game, all thanks to the power of math.
This has been an amazing deep dive. I never thought I'd learned so much about math from playing Dobble.
Me neither. It just shows that math is everywhere, even in the games we love. So next time you play Dobble, remember all the cool math working behind the scenes.
I definitely will. And maybe I'll even try designing my own Dobble deck with my friends.
That's the spirit. Keep exploring, keep asking questions, and remember that math can be an exciting adventure. Thanks for joining us on this deep dive. Until next time, happy gaming.